So in this case, we are going to continue with our matrices working with the scalar multiplication. All right, as we had before, we saw that the scalar multiplication is part of our syllabus where you need to understand the operation of a scalar. Just like what we had before, when we worked with the vectors, given a certain vector and there is a scalar that is outside, we saw that the effect of a scalar was to multiply each and every term that you are given on that column vector. So it is the same thing even for the matrices. When given a scalar and there is a matrix that you are having, to the number that is outside of the matrix is referred to as a scalar. So that can be a constant K. All right, so given a constant K and we've got A, B, C, D as a matrix, the effect of the constant K, the scalar, multiplies every term inside. All right, so K is going to multiply each and every term inside. K times A, K times B, K times C, K times D. So that is the effect of the scalar. So in our case, given a matrix 2, into this. So you have to multiply 2 times this matrix. You multiply 2 times every term. 2 times what? 2 multiplies minus 3. 2 times minus 3. Yes, you get right, guys. Here, 2 times minus 3. But this one, you can even perform it in your head. In your head. You can perform the calculation, guys. 2 times minus 3 is what? Negative 6. Then you move on 2 to what? 5. 2 times 5 is what? 10. You are done with the first row. You multiplied every term, and then you move on to this one, which is below. So you do the same. 2 multiplies what? 4. 2 times 4, that is 8. 2 times 1, that is a 2. So this is your scalar multiplication. You've simplified. So let us avoid too much calculations, guys. That is too much calculations. Some of the calculations, you can perform it in your head. This to this, this to this. You write it down. Okay? So this is what you can be given, right? It can be a fraction. It can be a whole number. It can be anything. Given minus 1 over 2, then we've got 4, negative 8, and this is 2, negative 10. Simplify or evaluate. So minus 1 over 2 is a scalar. The effect of a scalar is that it multiplies each and every term inside. So that is minus half times what? Times a 4. This is 2 into 2, 1 into 4, that's 2. So minus 1 times 2, that's minus 2. Minus half multiplies what? Minus 8. So that is minus 1 over 2 times minus 8. Right? So 2 into 2, that's 1 into minus 8, that is minus 4. So you multiply here, minus 1 times minus 4. That's what? A positive 4, negative times negative. All right? Minus 1 over 2 times what? Times 2. Minus 1 over 2 times 2. 2 and 2 cancels, so you're left with what? Minus 1 times 1, which is minus 1. Then minus 1 over 2 times what? A negative 10. A negative 10. So this was going to give us a negative 5. Then here, negative, negative, that's what? A positive. So it is issue of what? Directed numbers. That is how you play around with what? The scalar multiplication. All right. So that's the basic operation. All right. So they can even give us a condition like this. All right. Let us just consider another example. Given matrix A is equal to 2, 3, 1, 4, and matrix B is given as, right, negative 1, 2, and negative 3, 5, like this. Then you are being asked to find A minus 2B, A plus 2B, A minus 3B, 2a plus b, whatever that you can be given, guys. Those numbers simply represent what? Scalars. They are scalars. So I'm just going to use one example, which is like this. So if you're asked to find a minus 2b, all right, so this is what we are going to have. Matrix A is what? 2, 3, 1, 4, like this. Then minus 2b, minus 2, matrix what? B. This is our matrix B, minus 1, 2, minus 3, 5. So you're asked to simplify this. So we talked about subtraction of matrices before, but in this case, there is what? A scalar. So the scalar here is the 2. The negative is for our subtraction. We are supposed to subtract. So you use the sign for subtraction. The number, only the 2 is the only one that you're going to consider in expanding this matrix, multiplying each and every element as a what? As a scalar. So this is what you're going to have. The first matrix remains as it is, 3, 4, 2, 3, 1, 4 as it is. All right. Then you consider multiplying by the what? The scalar. So the negative 2, the negative, I mean here, this one remains. This one is for subtracting, all right? So that is the negative there. So here you multiply by the 2, only 2, all right? So that we do not miss out what's going to happen here. So 2 multiplies what? Negative 1. 2 times what? Negative 1. That's a negative what? A negative 2. Then 2 multiplies 2. 2 times 2, that is what? That is a 4. The same here, 2 multiplies negative 3, which is negative 6. Then here, 2 multiplies 5. 2 times 5, that is what? Positive 10. Then you subtract. Take note, you have that negative here. You never used it on the multiplication. So now you are going to subtract. Some, they use the minus 2 as it is to multiply here. If you use the minus 2, the sign changes to a positive here. You add it now. When you use the minus 2 to multiply everything, then here you must change the sign to a positive, which many of you guys, you forget to, right? So that's why I'm saying just ignore that, multiply with a 2, then use that negative now to subtract here. Remember the concept that we had before about subtraction, addition of matrices, corresponding elements as before. So 2 corresponds to minus 2, 3 corresponds to what? To 4. 1 corresponds to minus 6, and 4 corresponds to 10. So their subtraction is possible. We have got the same order, a 2 by 2 and a 2 by 2. So you can simply subtract 2 minus 2. So take note what you're dealing with. 2 minus, you are subtracting what? Minus 2. So that's minus and a minus, which is going to give us a positive, right? So that's 2 plus 2, which is what? Which is a 4. The same thing here, 3 minus what? 4. Corresponding elements, 3 minus 4. So that's simply 4 minus 3, which is 1. Then we take the sign of the bigger number, so that's a negative 1. Okay? So we are done with the first part. We move on to these ones below. So 1 versus what? Negative 6. So it's 1 minus 6. Take note. 1 minus, what are we subtracting? Minus 6. So negative, negative, a positive. 1 plus 6, that's what? That's a 7. Okay, then we move on to another part, which is the last element, 4 minus what? 10. 4 minus 10. So that's 4 minus 10, which is simply 10 minus what? 10 minus 4, that's 6. Then you take the sign of what? The bigger number. So that's a negative 6 at the end. So you see, guys, the scalar multiplication can be applied where also we are to consider addition and what? And subtraction of matrices, but we have the scalar multiplication in a concept. So it's all about revision. Let us do revise as much presence as we can till we meet again.